classify this quadrilateral. So how the heck are we going to classify that quadrilateral down here? First thing is we took away your what? We took away your coordinate grid. So how are we going to deal with that? So when we take away your coordinate grid, I still like to have a visual down there. Again, you can't bust out graph paper. The idea behind that one is how you can deal with it when there's graph paper there. I'm still going to make a visual, but it's not going to be a fancy visual. What the visual is going to be there for is to get my 4 side links and just to kind of keep track of my sides as I'm finding them. So y'all can kind of visually, or you all can kind of mentally graph that. Where's -1, -4 at? -1, -4 is G. -4, -1, not as far down. Where's 2, 5? What is that? I. And 5, 2. GHI. Okay, and that's F. So make it. And again, that is not a great picture. It's just again to get a visual and to name those 4 side links. If you don't get a visual to name those 4 side links, which you might accidentally name instead of a side link, what I've seen students do is accidentally do this. They say HF. And what is HF actually representing then? It's a diagonal. Okay, we can do some work with diagonals, but we ain't there yet. Okay, so that's what I did. I did that on my notepad off to the side as I was making the answer key. I scratched off to the side. I said HI, IF, FG, and HG. And then what did I do there? I didn't go make triangles because I didn't have a coordinate grid. What did I use? I used my good old correct. So if I don't have my coordinate grid, I'm using my good old distance formula right there. Okay, and I did that not once, not twice, not thrice, but 4 times. Okay, so that's what I'm doing there. That's why I said you're gonna get good practice with that distance formula, especially when that quadrilateral does not have a coordinate grid right there for you. So that's what I did with HI. HI, I took the coordinates, plugged them on in. So where's HI at? All right, HI is right here. And that's what I did on my notepad off to the side. X minus X squared plus Y minus Y. So 5 minus -1 squared. And then I went to my calculator and I plugged that into my calculator like we've been doing, guys. That should be not anything, oops, wrong button. That should not be anything too crazy off of that with your calculator as we've been doing. But as we said, don't plug that in with the square root symbol, because if it doesn't turn out to be perfect, your calculator cannot handle that. So as we type that on in, I should be getting, or not should, but I do get 72. That's not perfect. So what I want you to do then is always simplify that radical down. We always work in the simplest radical form. So take 72 off to the side, simplify that radical, and the square root of 72, however you want to do that. Square root of 72 gives you that 6 root 2 off that. Okay? You get 6 root 2. And then I repeated that 3 other times. I repeated that for IF, HJ, and FG. And what I found is those 4 side links. Okay? Now, if those 4 side links, if you just did that, especially with no picture, and you didn't do any slopes, what other shape is out there with those 4 side links? Rhombus is all sides, it's the same. It could be a parallelogram. I don't know if it's a rectangle or parallelogram right now. It could be a parallelogram. Parallelogram's got the same options going there. Parallelogram has 2 opposite sides congruent. But what makes the difference between a parallelogram and a rectangle are then the slopes. Are the adjacent sides perpendicular or not? And that's what I did one more time, but using my slope formula. So again, bring in your slope formula, guys. All that stuff from your 6th grade, 7th grade years coming into play there. Distance formula, we've been doing that for about 2 weeks' time now. Okay, HI, again, what I did on HI, I did y minus y over x minus x. Okay, go back to 6th grade, 7th grade, 6 over 6. That's where I got 1. I did the same thing for IF. IF, 5 minus 2, and 5 minus 2, 2 minus 5. And when I do that, I get a negative 1. And what that tells me is opposite reciprocals are there. Opposite reciprocals are there. That means my shape is not a parallelogram. I can go, well, it's a type of parallelogram, but it's a more specific type. It's a rectangle. Okay, I get myself a rectangle. A rectangle is a specific type of parallelogram. So that's why we say it's a rectangle, because of the adjacent sides are perpendicular, because those opposite reciprocal slopes, and the opposite sides are congruent. Okay, so that's the big one. If that's probably about as worse as it's going to get. That number 3, that's about as worse as it's going to get for you. If you can do number 3, relatively cool, and that's as bad as it's going to get. If you can do all the distances, do the slopes, tell me what you got there. That's as ugly as it's going to get. It's not going to be really any worse than that. All right, on to the back side we go. Anything on the back side you guys are looking at? Just quickly talk about on the back side. Just looking on the back side there. Anything on the back side you guys got? Yes, Milana. Number 9? Sure. On number 9, find either circumference. So if you're going to find the circumference, you guys got to know your right formula. You're going to have 5 formulas we use throughout the school year. Your 5 basic formulas: area of a rectangle, square, triangle, area of a circle, and circumference. Those are your 5 basic formulas you've been using since, I don't know, elementary, middle school. We're going to keep running through them. We'll add on a couple new areas this year, but those are your 5 basic ones. Now, circumference formula. What did we say yesterday for circumference? Circumference is 2 pi r. So from yesterday, got to know what the radius is. And then she asked about number 9. I don't know what the radius is. They tell me the area is 64 pi. So we did this backwards. You got to take it backwards. If the area, which is pi r squared, area of a circle, okay, area of a circle is pi r squared, what is the radius then? If I could write this correctly. What is the radius? Okay. Now you should be able to look at that and just say quickly, the radius is what? The radius is 8. If you're not looking at that, what we're doing algebraically is we're dividing by pi, and you're square rooting that thing. That's what's going on algebraically. You're square rooting that 64, and the square root of 64 is 8 plus a minus. We toss the negative. And that's where I get 16 pi now. Plus you. That's where I'm getting that 16 pi. 2 times the radius. What's 2 times 8? Yep, that's where I'm getting that 16 pi at. Okay. Units for circumference. Circumference is around the circle. That's the distance you walk around the circle. So that's where I'm getting that 16 pi at. Okay, anything else on the back side you got? Take a picture from last night? Yes.
10.
Which one?
10.
10. All right, let's get 10 there, down below. Okay, give me the diameter. Now, diameter is not a formula there. Diameter is just diameter. But on number 10, it says, hey, given the area, find me the diameter. So we're going to do the same thing we did right here. We have the area, we got to work it backwards. The area of a circle is pi r squared. So we got to go backwards, and what that's going to take us to is the radius. Divide by pi. What squared gives you 16? 4 does. Now that answer is not 4, because the radius is 4. But what do we need? We want the diameter. So the radius is 4, the diameter is then 8. Double it out. Okay. Anything else anybody's got? 12 is your call. 12, I'd say 12 is the one I was curious about. 12 is one of our SAT style questions. So 12 being our SAT style question, let's think about this. Here's the origin, x, and then y is at like -4, -4. Okay? M is the midpoint. So M is the midpoint right about there-ish. Find me the length of my. That's all I want to know is what's the length of my. All right, with that, I don't even care what the midpoint is. It doesn't have anything to do with it. If you can find me what the length of xy is, whatever the length of xy is, what are we going to do with the length of xy? Just cut it in half. So what I'm going to do then is, what we did on the other side, do distance formula, x minus x squared plus y minus y squared. And whatever we get, we're going to cut it in half. My last period asked the same question. Some of them said, hey, find the midpoint. And then do distance formula of my. Cool, but you don't need to do that. We could just go straight to find me xy, cut it in half. So that's what we ended up doing. Bless you. -4 minus 0 squared plus another -4 minus 0 squared. 32, it ain't perfect. So simplify that radical for the umpteenth time in here. Something that gives you 32, start it off. 2 and 16. And what do we know about 16? 16 is a perfect square, right? Shortcut yourself. Square root of 16 is 4. And we're done. 4 square root of 2. Hey, with that 4 square root of 2, cut it in half now. That is the length from x to y. That is the length of xy, the full segment. But I don't want the full one. I only want half of that. So what's half of 4? That's where I'm getting that 2 root 2 from. That is a good SAT problem. Okay. So as I told you, I'm going to keep leaving those in throughout the year.
When are SATs due?
April. All right. Anything else you guys got? We're going to do more work with all this today and this week. So, like on that number 2 and 3 on the previous side, distance midpoint formula classifying, still going to happen today, this week. So with that in mind, before you go and throw it into the basket one more time, make sure you have a completed assignment to turn in. If it is, make sure your name's on it, throw it in the basket, and get out the books. Turn to page 65, I think it is. 65, everybody, and you need your calculators out. 65. Hey, you're gonna get some tonight. Yep, I promise you're gonna get some tonight. All this week, Jane, I got more of those to do because I know those are kids struggle. 65, everybody. 65. All right, on 65, we are doing, as I said, the exact same thing. The only difference is we're going just one step further. We're going to find the equator area now, these quadrilaterals and triangles. We're going to continue to classify. But then after we classify this quadrilateral, we're going to find the equator area of that specific shape. So on page 65, they started off very nice for us. We don't have to determine what shape we have in front of us because, well, on page 65, they told us specifically, hey, what shape is in front of us on page 65? Rectangle. So we don't have to determine if it's a rectangle. We just got to go figure out the dimensions of that rectangle and know what formula area of a rectangle is. How do we calculate the perimeter of a rectangle? Which we know how to do that. But if we don't know what shape is in front of us, we have to go do the skills that we've been doing over the last week. We have to go classify the shape in front of us, and then once we know what shape it is, we then go choose the right formula to calculate the area. You're not gonna use the area formula of a circle for a triangle, are you? You're not gonna use the area of a square formula for a triangle, correct? So you have to make sure you use the right tool for the job. So as I keep rattling on here, go get me the dimensions for that rectangle up there. What's the dimensions of that rectangle? Real quick, guys, and go give me the perimeter area. Go answer out A and B real quick. Shouldn't take you more than like 30 seconds. You know how to get the perimeter area. I'll give you the dimensions of that rectangle. It's nice, good stuff. Horizontal and vertical side lengths. Those were nice. They were nice to start off today with. All right, what's my dimensions? When I say dimensions, that's my length and width, my base and height. What's the dimensions of that rectangle, guys? 2 by what? I say it's a 2 by 6, right? So what's a 2 by 6? Perimeter, walk it around, add up all of our sides, right? 2 sides are 6, 2 sides are 2, and then 12 plus 4, right? Which is a grand total of. Now, do I have any units on this one, they say? Nope. Just remember, as we've been doing it, perimeter is just units. That is you guys just walking on the ruler, walking on the number line. That's one dimensional. Okay. How are we going to find the area of a rectangle? Go back to our 5 formulas. Area of a rectangle is what again? What's that? Base times height, right. Length times width works for you too. That's fine. And I'm not 100% sure. They're back there. I have to take a look at it. I'm not sure what SAT formula does, but those are interchangeable. But 2 by 6, and 2 times 6 is 12, right? Units. And now area is 2-dimensional. We say squared. Okay. All right, let's flip it. Let's jump into the next one there. Up at the top of that page, same deal. Go find me the perimeter area of that rectangle on the top. What jumps out to you on that next page? What jumps out to you on that next page, guys? Anything jump out to you? What's my dimensions then? 6'3". Hold on then. What's going on there? They're not what? Yeah, my scale's messed up, isn't it? So when I heard 6 and 3 right here just a second ago, that'd be fine if we're going by ones. But my scale is not an obvious scale, is it? No. So that's what SAT likes to do. That's what this book also is practicing you for. Make sure you're paying attention to the scale. So I'm looking at this 300 right here. 1, 2, 3, 4. 300 divided by 4. That's how we're calculating that scale. 300 divided by 4 is, each tick mark is 75, right? So my scale is going by 75. Is it doing both the horizontal and vertical by 75 then? Yes, it is. Right. So Tyler originally said 3 by 6. So 3 is actually going to represent not 3, but 3 times 75. What is it? 225. Right. Make sure, again, reading that. And then the horizontal one, he said 6 originally. 6 times 75 is what again, Tyler? 450. Thank you. Now, where else do you see that happen quite a bit? If anybody's taking geography classes, I mean, it happens all the time on maps, right? With your maps, you take the real world and shrink it down. This is getting into what we talked about was cartography, map making. Okay. Now here, nothing big now after that. Just going and calculating quickly your perimeter and area. 2 sides of what? 225, and 2 sides of what? 450. Check me. 1350, guys. And then if you haven't done so yet, go get your area. Two sides again of 225. Oops, sorry, nope, shut up, Dave. 225 times what? 450. 101,000. 250 square units. Okay. Watch your scales. Biggest thing I can tell you. All right, let's start jumping around a little bit. Now, as we jump around to the next page, we're going to take that same rectangle and let's talk a little bit about what we're going to lead into the next lesson with, next topic with. If we took that that rectangle, and it says, hey, translate this rectangle, taking point R, such that point R moves to the origin. So it move here to the origin. What is happening to that rectangle? What does a translation mean? Anybody describe what a translation is?
Just a movement.
What type of movement? Do you know what type of movement happens with that? Because there's different types of movement out in geometry. Remember what a translation looks like?
I think it's just moving it down or up.
Yeah, it's like a down or up or left and right, correct? It's a slide.
No rotations.
No rotations, right? No reflections. We're going to talk about those later on. Those are what we call transformations. The translations is a different type of it. Now, my big question to you is it changing the shape and size of it then?
No.
No, it's not, isn't it? All it's doing is changing what? It's changing the coordinates, correct? But it's just keeping the same shape and size.
It's like where you would you don't change the meaning.
Correct.
Where it is.
It's just changing where the location is. We call that in math, we're going to call that an isometry. We're going to talk about that. My sophomores, we did some work with that last year with moving the absolute value graphs. All right. Now we did change the shape of it, but we are going to talk about that later on. But when you keep the same shape and size, keep same shape and same size, we call that a special type of transformation. We call that a isometry. The translation that you just said, that is what we call an isometry. What Tyler alluded to, a rotation, is an isometry, same shape, same size, and also a reflection. We call that a same shape, same size. We call that an isometry. We're going to look at those, I think, in the next topic. But again, does it change anything about anything? Moving things to the origin are nice sometimes because 0, 0 is nice to work with, isn't it? Okay, it should be nice to work with. But bless you. All it really is kind of getting you into here is asking you, is it changing anything about the shape and size of it? No, it kept the things the same. All right, that's all I was asking about. We're just going to talk about it. We're going to move. Now let's go do this. Okay. All right. What's it say here? Determine the perimeter and area of that quadrilateral. All right, guys. What formula do you want to use on this quadrilateral? We got a bunch of formulas here, perimeter and area. What area formula do we want to use here? Perimeter, add up all the sides. Who cares? But what area formula? We have area of a rectangle, area of a square, area of a triangle, and area of a circle. Those are four areas. Makes sense to probably use a square. How do you know it's a square though?
And it's 4 equal sides.
How do you know it's 4 equal sides?
It tells us that it's a quadrilateral.
The quadrilateral, there's more than one type of quadrilateral out there. Darn, I know. I'm being an ass here. All right. What's that? We got to go find the slopes. Okay. Now, somebody said it's all equal sides. How do I know it's all equal sides? Have you shown it? You know it's all equal sides yet? No, you have not. So, Jaden asked me a few minutes ago, and Justice asked earlier too, about getting going through, making sure we're kind of good on that. Just a little bit more practice here. You can't choose the formula until you determine what shape is out there in front of you. Okay? They didn't tell you it's a square, did they? If we did, if we could, imagine if I erased out this picture and all I said is, hey, L is located at -4, 4, and listed out the coordinates. O is located at 2, -2. All I did was give you the coordinates, but I took away your coordinate grid. Can you easily tell me then what shape is in front of you then? No. So you got to go first and figure out what shape is there. you gotta go figure out, is it a rectangle, square? Hopefully you don't say it's a triangle, okay? But you gotta figure out what shape is there in front of you. So let's go and start off by proving it's a square. And how do we prove things? We start off by looking at the side lengths. Right. Let's go prove the side lengths. Okay. Give me guys, start naming the sides. We've done this already. I'm sorry, what was the first one you said? LM. Thank you. Nothing's changing. All right, we're still doing the same thing. Then walk it around. LO. And then what? NO.
Not sure if this is
And-
useful or not,
And what's the other one? MN. I'm listening.
but two of the sides have a slope of 1 and two other sides have slope of 2.
Give me a second. We're gonna absolutely. It's definitely useful. That's gonna be the next part. Okay. So you all told me at some point we got to do the sides. And that's gonna help us no matter what. We got to find the side lengths. So go do the side lengths. That's what we're doing. Okay. Make your triangles. It is on a coordinate grid. It makes my life a lot easier. I don't have to do the distance formula. So we're gonna go do those. Do our right triangles. Use Pythagorean theorem. Everybody should be doing that. We've been doing that now for a solid week there. As you make those right triangles, okay, it's then going to in turn also help us with the slopes, as Tyler said a second ago. Now pay attention here, because I screwed up first hour. Somebody called me out on it first hour. That's good. What's my scale going by, guys?
2.
No, you're right.
Yeah.
It's going by twos. So when you identify those right triangles, it's not 3 and 3, is it? What's my legs?
6 and 6.
6 and 6, correct. And I have triangles then that are all 6s around. Okay. So go then take it off to the side. Now, the nice thing is you do one Pythagorean theorem, you just set it all, right? So go do that Pythagorean theorem off to the side. Square root of 72 is what you're working with, right? Again, this should be pretty quick for you at this time of the game. Square root of 72, somebody down the simplest radical form. Survey says 6 root 2. Yep, Chikaya's up here. Make sure you're getting 6 root 2. Now, if we weren't getting all the same around, we had to go do the other ones individually, but this was a nice one. Now again, if imagine you don't have your picture here, what's another shape that could have all sides equal? Square or a, again, we're just imagine we're classifying. So if you just say it's a square right now, I'm gonna knock you out and say, nah, it could also be a rhombus. What's the difference between a square and a rhombus? Plus it. You said the slopes were 1 and -1. So we gotta now go show it is a square, and we gotta go prove what Tyler said. Let's go identify those slopes. Y'all told me it's a square. Show me it's a square. Show me those slopes. So Tyler said 1 and -1 in the first hour. That's exactly what we got. But show me that that is a square. Pretend we're not even finding perimeter and area in this problem. Just pretend we're classifying this quadrilateral, which I'm going to totally ask you on quiz Tuesday and the test Friday. Again, Jamie asked me for more practice. This is exactly what we're keeping with, okay? So with that, find me those slopes. And then LM is what? Positive 6 over 6. Positive 6 over 6 is 1. Walk it around. LO. Negative something. Negative 6 over 6, which is -1. And O is going up. Positive 6 over 6 is 1. And then NM is -1. All right, Tyler. So you said those were 1 and -1, right? What type of slopes are those then, guys? Thank you, Grace. That's what we're on a hunt for. If you're thinking it's a square or a rectangle, I'm looking for these opposite reciprocals. Sweet, we're good. We can now say we officially have ourselves a square. And again, why are we saying it's a square? sides are congruent. And why else? The adjacent sides are not opposite reciprocals. Adjacent sides are first what? The adjacent sides are perpendicular. The reason why they're perpendicular is because what you just said.
Yeah.
Adjacent sides are perpendicular because these slopes are opposite reciprocals. Okay. Again, I know I'm being picky on that, but that is the way that those should be written at the bare minimum. Adjacent sides are opposite reciprocals. It's not quite the full meaning there. But perpendicular, and why are they perpendicular? It's because the slopes are opposite reciprocals. Alright, you officially have yourself a square now. Now you can officially reach into that tool bag and pull out what area formula then? Side squared. Yes. Again, I know we took a long way to get to that point, but you gotta make sure again we have the right tool for the job. It is a side squared. And now give me the perimeter area for that square. Alright? Because if it is a rhombus, alright, if it out to be a rhombus, finding a rhombus is different from finding the area. Do you know the area of a rhombus? No. We haven't talked about the area of a rhombus. We can do it, we haven't talked about it yet. Okay. So from there, finish it off, guys. Excuse me. What do we say? 6 root 2, I think it was. 4 sides of 6 root 2. What is that?
A very big number.
24. Root 2, right? Go back to the beginning of the year when we had worked with radical work. Again, I told you everything's going to keep kind of coming all together in one problem. This is those one problems all together. Brought in our distance formula, our Pythagorean theorem, radicals, perimeter and area, classifying, slopes, tons of work. Directions say round that to nearest hundredth, I think it is. What is it rounded to nearest hundredth? 0.94, right? 33.94 units. As we've been doing the last, again, week or two. Making sure you round correctly. This is a gigantic problem. And lastly, they ask you for the area. Area of a square, you said is S squared now. Does parentheses matter? Yes, it does. So, go back. Don't need a calculator, but you can. Remember, if you don't use those parentheses, it's going to be a bad time. And when you plug it in, you better make sure you're paying attention to your calculator. As I typed it in, not paying attention, I cut my parenthesis. Your calculator is just going to go straight to underneath the radical. That's not going to be correct. You better make sure when you typed in that, you need to put it underneath of that. You need to move it from underneath of there, close it, yes, and then hit squared. You should be getting 72. And there's no rounding needed for that, is there? Units are squared. Okay. Now, on the quiz, on the test, when I do this, when I grade it up for you guys next week, all right, here's how this is going to roll. When I grade your lengths up here, each length is going to be worth half a point. So this length part up here, this is worth 2 points. This is worth 2 points for the slope. So this is worth 4 points right here. Down here on your explanation, that's worth 3. 1 coming from, did you choose the right quadrilateral? And then a half a point coming from your explanation. 2 points coming from your explanation. Did you include parts about the side links? Did you include parts about the slopes? So there's 3 points coming from right there. So what is that? That's like 7 points right there in that problem. And then lastly, point and a point. Did you correctly calculate the perimeter? Did you correctly calculate the area? That's a big problem right there, all together. Don't screw it up. All right, last part, go calculate me the perimeter area. Now at this last one, technically we should be classifying it, but just for our time's sake, we're just gonna calculate the perimeter area of this triangle. Clearly, you can see, hopefully, it's a right triangle. So, let's go calculate the perimeter area of that right triangle. Somebody, what's my vertical leg? Yeah, what's my length of my vertical leg? What's my length of my vertical leg? Look closely at that y-axis. What's the length of my vertical leg, guys? Starts at what? Ends at what? Somebody said, yeah, it's at 8, right? Starts at, hey, this is going by 2's, isn't it? -1 to -9. So that's a length of 8. So the y-axis is going by 2's, correct? Now pay attention on the x-axis, because my last period, a couple of them were not paying attention. Assume the x-axis is going by 2's. Is the x-axis going by 2's though? No. No, what's the x-axis going by? Back to 1's, isn't it? So what's the length of my horizontal leg? Ooh, check it again. -5 to 3 is, it's another 8, isn't it? So when I look at that problem, or that triangle, that's an isosceles triangle. Does it look isosceles? Definitely not. We don't go by looks, because this problem is they change the scale on us. It's a stupid problem like that. Go find me my, whatchamacallit. Go find me my hypotenuse now. How are we gonna go find the hypotenuse? Go use good old, what's the only thing we've been using? Pythagorean theorem, right? Don't know trig yet. Trig will be coming. Let's go Pythagorean theorem. What's going on there, Sophia?
Should I put, it wouldn't be 16 since it's going by 2's too.
This one's not going by 2's though. 1, 2, 3, 4, 5. Yeah, they changed up the scale on the x's and the y's. Yep, I know. It's annoying. Which is definitely possible for
Wouldn't it make
things
it a
to
lot
happen like
shorter
that.
if it was all increased?
Well, they would have adjusted the picture for that. Yeah. Just pay attention to scales, guys. 8 squared gives you 128. Simplifies down to somebody. 8 root 2. Jakaya's saying 8 root 2 up here. I agree with Jakaya. Let's finish this thing off. Perimeter and area. Perimeter and area. We got our 3 sides. Thanks to Jakaya. We got 8 root 2 for the hypotenuse. 8 and 8 are our 2 legs. Back to now beginning of the year. That algebra backfill we've been doing. Add up like terms, guys. 8 plus 8. Can you do anything else with that? Those are not like terms. Don't combine them. That's as good as it's going to get. Okay? 16 plus 8 root 2, that's my exact answer. Now, I do believe it asks you to round it again to nearest what? What's it say there? Did it say 100th again?
Yeah.
Okay, so let's go back to our calculator. Let's punch it in. 16 plus what? 8 square root of 2. Enter. 27.31, right? So we're going to keep going to exact and approximate. Read the directions. I'll tell you how to round on the quiz and the tests. Just looking at it again this morning, I'm going to keep doing that same thing. Finish it off. How do I calculate the area of a triangle?
It's just the base times a half.
Times a half. 1/2 base times height. What is my base and height here? 8 and 8. It's got to be perpendicular. So 8 and 8 are the perpendiculars. What is 8 times 8? And half 8 times 8 is 32. Half of 64 is 32. And is any rounding required? No, right? Half of half. Half of 64 is 32. No rounding required. Okay?